Welcome to a lesson on alternate interior angles. If we examine those words, the word alternate meaning on opposite sides of the transversal, interior meaning inside the parallel lines. Our interior space is all of this space that extends indefinitely between the parallel lines. And so when we examine the pairs of angles that satisfy this name, we're looking for angles that are inside those parallels, like 3. Pardon the scrolling, that happened once before. Let's take a look at 3, and if the one that's alternate to it and interior would be 6. Those are an angle pair, and also angles 5 and 4 are considered to be a pair of alternate interior angles. When the transversal crosses a parallel, those are equal in measure. Let's take a look at a specific example. In this diagram, you can see that we have an angle measure marked 115 degrees. Notice that angle 1 is an alternate interior angle to that angle. That means that the measure of angle 1 itself is 115 degrees. It's the same. And notice angle 2 is also marked. Since angle 2 is a vertical angle to angle 1, it would also have the same measure. So it would be 115 degrees as well. Let's take a look at an algebraic connection. In this diagram, you can see I have the alternate interior angles that have labels. They're going to be equivalent in measure. So what we can determine is the measure of the top left angle there, called 4x minus 10 degrees, is going to be equal to or the same as 58 degrees. Solving this algebraically, if we were to drop the degrees symbol, add 10 to both sides of this equation, we get that 4x is equal to 68. Then we can divide both sides by 4. 68 divided by 4, I believe, is 17. So if the question asks us for the value of x, there we go. If the equation asks us for the measure of a given angle, we could plug back in, but you should already assume you know the answer, because if we're to plug in 17, we should expect to get out 58 degrees. It should match that. I hope that's helpful.